Hello everyone, welcome to another video of our series Let's Learn Data Science Together. In this video, we will be learning about the data preparation phase to model the data. What is data preparation and why is it essential? Data preparation is an essential step in data science workflow that involves transforming of raw data into a suitable format for modeling. It's an important phase because well-prepared data enhances the accuracy and efficiency of ML models. Because if we have proper data prep, so we can get better insights and more reliable predictions from that data. In this section, we will be covering the following points: how to partition the data, balance training data set, build cart decision tree using Python, build C5.0 decision trees using Python, and building random forest using Python. So this video might go a little longer. Stay patient and keep learning. Let's keep learning together. So how to partition the data? Data partitioning is the process of splitting data set into separate subset. Typically, we use two subsets for the same, that is training and testing purposes के लिए training dataset and testing dataset. This is an important step in machine learning pipeline because it allows us to evaluate how well our model performs on unseen data. So the two main subsets created during this phase are training set and testing set. Training set क्या होता है? It is a subset used to train the machine learning model. And testing data set क्या होता है? It is a subset used to evaluate the performance of the trained model. और टेस्टिंग डेटा सेट के लिए ये जरूरी है दैट जो भी वो डेटा सेट दे टेस्टिंग के टाइम पे दैट शुड बी अनसीन सो दैट वी गेट एन अनबायस्ड इवैल्यूएशन ऑफ इट्स प्रेडिक्टिव कैपेबिलिटीज. इसमें दो न्यू टर्म्स है, ट्रेनिंग सेट एंड टेस्टिंग सेट. Training set is a portion of the data set which is used to fit the model, and testing set is a portion of the data set which is used to assess the model's performance after training. The random state will be a term used in later part of this video, so we should know about it, that it is a parameter used to control the randomness of data splitting, कि data कितना randomly split हुआ है. Setting a random state ensures that the results are reproducible. What is the importance of data partitioning? The two main things are evaluating the model performance and avoiding overfitting. Avoiding overfitting कैसे? A model trained and evaluated on the same data may perform well but fail to generalize to new data. So partitioning mitigates this task. Moving on to the coding part. सबसे पहले लाइब्रेरी को इंपोर्ट किया, sklearn.model_selection को इंपोर्ट में से इंपोर्ट किया training_set_split वाला फंक्शन. So we are importing the required module. We will be going through, line by line breakdown वाला explanation. अभी देख लेते हैं मेजरली कर क्या रहा है. फिर उसके बाद डेटा सेट को लोड किया. फीचर्स एंड टारगेट वेरिएबल्स को वी आर सेटिंग by using .drop and a column purchased as the target variable, then splitting data set into training and testing sets, which we will be working on, and then checking the original data set का shape. What is shape? Dimensions. What are dimensions? Rows and columns के numbers. I'll show you the data set first. This is the classification with name underscore वाला data set. Here we have name, age, salary, purchased, gender, country, 20 rows, and 1, 2, 3, 4, 5, 6 columns. Let's get back to our coding and run it. So we have 20 rows and 6 columns. In the training shape, we have 14 rows, 5 columns. In testing shape, we have 6 rows and 5 columns. ये क्यों? क्योंकि एक कॉलम हमने ड्रॉप कर दिया था, कौन सा वाला? परचेज वाला. एंड इसको हमने टारगेट माना था क्योंकि इसलिए इसको ड्रॉप कर दिया. तो कॉलम्स अपने एक कम हो गए एंड रोज अपनी स्प्लिट हो गई ट्रेनिंग और टेस्टिंग डेटा सेट में, एंड इसकी टोटल नंबर ऑफ रोज इज इक्वल टू द ओरिजिनल शेप की टोटल नंबर ऑफ रोज. Now coming on to the explanation of the code. सबसे पहले we are importing our modules of the functions, which is pandas and training_test_split function from sklearn_model_selection, which randomly would split the dataset into training and testing set based on specified test size. So we also talked about sklearn.model_selection वाली library. So ये वाली library से हमने train_test_split वाला function import किया है, which will divide our data set into training and testing data set. So वो arrays को split करके रैंडम ट्रेनिंग एंड टेस्टिंग सेट्स में डिवाइड कर देगा. Then you already know how do we load the set. The data frame name is equal to pd.read underscore csv and then the path. Then features and target variables कैसे सेट किया है. x is equal to data dot drop bracket में we have written column name and then axis is equal to 1. Axis is equal to 1 से क्या होता है, we are dropping a column, ये specify करता है. And if we had written axis is equal to 0 तो वो रो ड्रॉप कर देता. डॉट ड्रॉप फंक्शन तो समझ आ ही गया होगा, उसने वो वाले कॉलम को कंसीडर नहीं किया है एंड डेटा फ्रेम में लेने से ड्रॉप कर दिया है. सो अपनी एक्स वाली डेटा फ्रेम में परचेज वाले कॉलम के अलावा एवरीथिंग है एंड वाई वाले डेटा फ्रेम में जस्ट द परचेज कॉलम. देन वी आर स्प्लिटिंग द डेटा सेट इनटू ट्रेनिंग एंड टेस्टिंग डेटा सेट. ये अपन ने 4 वेरिएबल्स ले लिए, एक्स ट्रेन, एक्स सेट, वाई ट्रेन एंड वाई टेस्ट. ट्रेन अंडरस्कोर टेस्ट अंडरस्कोर स्प्लिट वाला फंक्शन लगा दिया. इसके अंदर भी 4 पैरामीटर्स दे दिए, कैपिटल एक्स, स्मॉल वाई. कैपिटल एक्स क्या था, स्मॉल वाई क्या था. कैपिटल एक्स इज द फीचर्स दैट वी आर टेकिंग एंड स्मॉल वाई इज द टारगेट. सो फीचर्स एंड टारगेट दे दिए. एंड देन टेस्ट साइज इज इक्वल टू 0.3 क्या होती है. टेस्ट साइज इज इक्वल टू 0.3. This is a parameter which will indicate that 30% of data will be allocated to the testing set while remaining 70% will be used for training. So total we are 20 and 20 rows का अगर अपन 70% निकालेंगे that would be 14 rows. So we have got here 14 rows for training and the 6 rows that is 30% for the testing data set. And we have already discussed what the random was. The random state was the parameter to set the seed for random number generation. Seed मतलब कुछ नहीं होता है. Seed एक normal parameter है जहाँ से वो start करेगा उसका randomization का process. This is an initial value which is used to generate a sequence of pseudo-random numbers. So by setting random state is equal to 42, we are effectively fixing the randomness of the splitting process. So जब random state is equal to 42 देंगे, we will get the same results in the splitting process. And then we are just outputting the shape to confirm कि दोनों की rows का जो sum है वो original data frame की sum के equal आता है कि नहीं. Now coming to balancing the data set using Python. So in certain classification tasks, the target variable might have an imbalanced distribution, meaning that one class occurs far less frequently than the others. This imbalance can affect the model's ability to learn from the minority class, leading to biased predictions. But हमें तो unbiased result चाहिए. इसके लिए example देख लेते हैं. So for example, in fraud detection, only a small fraction of transactions are fraudulent. अब अपने पास fraudulent transactions ही बहुत कम है एंड उसके ऊपर अपन ने मॉडल को भी इम्बैलेंस डेटा सेट में ट्रेन कर दिया. So it may default to predicting non-fraudulent for all transactions to achieve high accuracy. अब तो वो fraud को भी non-fraud बता देगा. So this will pose a problem, even if it fails to identify the actual fraud cases. So this makes the model ineffective and ऐसा मॉडल कोई काम का नहीं होगा अपने लिए. So to address this issue, the training data set can be balanced by resampling records of the minority class. So how can we resample it? By increasing the representation of minority class. The model gets more examples of each class, improving its ability to learn from all types of records. We can also discuss a few techniques for balancing data. 4 main techniques है: oversampling, undersampling, smooth and class weights. Then we will go on to discussing the process of resampling. Oversampling में we can increase the number of instances of minority class. Undersampling में we can reduce the instances of majority class. Smooth and synthetic minority oversampling technique. Here we can generate synthetic samples for the minority class based on the feature space, and class weights is an algorithm which allows us to assign weights to classes, giving more importance to the minority class during the model training so that we can get an unbiased approach. Now coming on to the resampling process. Resampling involves drawing samples from minority class with replacement. So what is it? We draw samples from minority class with replacement. Majority का निकाला, minority का डाला. ऐसे करते करते we will go on in the resampling process. For example, if the goal is to increase the percentage of fraudulent cases from 1% to 25%, additional samples are drawn from the minority class until the desired portion is reached. So to reach the desired proportion, We continue doing this process by adding, by drawing the samples from minority class. So we just get the samples of minority class and keep working upon them. इसके लिए जनरल फॉर्मूला क्या होता है? We can just go through the mathematical formula as x is equal to p into records minus rares whole divided by 1 minus p, where p is the desired proportion of minority class, record are the total number of records in the unbalanced data set, and rare is the current number of records in the minority class. So we can just take an open example of Python. सबसे पहले हम क्या करेंगे? आइडेंटिफाई करेंगे records of the minority class. df is the data frame, as you all know. From the response column has yes or no. So if response is equal to yes, is being considered as a minority class with 338 records out of total of 3089, which is about the 12%. So ये वाला एक example consider किया है कि इसमें minority class के records है 338, which is 12% of the total records. So we have now identified the minority class by using the dot value underscore counts function. Then we are calculating the number of additional samples which are needed to increase the responses to 30%. So यहाँ पे formula apply कर दिया जो ऊपर discuss किया था. What was the formula? P into records minus rare upon 1 minus P. The same formula. P into records minus rare upon 1 minus P. So the result would be approximately 841. Now we are taking two different data frames again to resample and resample. Data frame name.loc जहाँ पे भी response is equal to yes है. Then replace कर देगा ये sample को. We will be going to the code when we discuss the code on our data set again. Then we combine the original and resample data concat वाले function से. Then we verify the distribution वापस से value underscore counts वाला function लगा के. I am so sorry, just a minute. So yeah, my page is going just wiggle. Getting back to our points. What will be the step-by-step guides to balancing our data? We can identify the records in minority class and calculate the number of additional samples needed. Then resample the minority records. Then combine original data and resample data using .concat. And again verify the distribution by using value underscore counts function. An important note to look for. Balancing should only be done on the training data set, because the test dataset must remain unbalanced to reflect the real-world conditions, ensuring that model evaluation is based on an accurate representation of real data. Coming to the code, first and foremost, we will import the module pandas, then load the dataset, then check for occurrence of each class in the column which we are targeting. Our target column for now is purchased. So we are checking for the occurrence of each class. First, we will print the distribution before balancing. How? By using value underscore counts function. While setting parameters for resampling, we give the desired proportion for minority class. Also taken a variable for recording the total number of records in the data set, and a variable rare which will have the data frame purchased, which is the column of which only has all the values as of purchased. Then dot value underscore counts function to count the occurrences of yes. Dot get will get is the occurrences of yes, and dot value underscore counts will count all of them. And if there are any records which needs to be resampled, if they are in the minority, so we will enter the if block and perform the further calculations by putting the formula, then resample, then R sample, then rebalancing, storing the resample data into a different data frame by using pd.concat, and then check for distribution by printing the distribution of values after balancing in the purchased column. And if there is no need to resample, we will enter the else block, then print that there are no records to resample anymore. Then we can add a new record which it can resample. So we are adding this record by pd.concat, then recalculating rare and x after adding the sample. Then we can separate it, resample it, and then check for new distribution. Again, after running, we get the desired output as class distribution before balancing. The name count data type is of count is int64. There is no yes records found to resample. Added a sample yes record for testing. Then class distribution after balancing, it is just the same. And the number of yeses was 8 in all. For now, you can just ignore this output because it would be much better if you take a bigger data set from Kaggle and perform the same operations on it. It will give you much better results. So going through the process again, first we load the dataset into data frame by using p.read_csv, importing libraries, checking class distribution in the target column. Our target column was purchased. So we are printing df bracket में purchase column का name, then value_counts function will count the number of occurrence of each class, that is yes or no, in the purchased column. Then we are setting parameters for resampling. P is equal to 0.3 will tell you the desired proportion of minority class, that is yes in the balanced data set. And we want yes to make up 30% of the total data, which it already was in the data set as we saw. Then in record, we are storing the length of data frame, which is the total number of rows in the data set. Then rare में it will get us the current number of yes class records in the purchased column, and if there is no yes, it would return 0. Then we check if there are any yes records to sample. If there are any yes records to resample, we will check it using this condition. And if there are no yes records, the code inside this block is skipped, as you know, if else condition, basic if else. Then we can calculate how many records are needed to be resampled by applying the formula, that is p into records minus rare upon 1 minus p. And then we resample the minority class, which we are assuming it as yes. Then using the concat function, which will concatenate the original data frame df and the resampled data frame rsample into a single data frame df underscore reval. That is rebalance. So for concatenation, we give pd.concat and bracket में frames के name दे दिए df और r sample वाली data frame को it will concat into df underscore reval, and index is equal to true वाला parameter के हो दिया. It will reset the index of resulting data frame, ensuring that the indices are sequential and continuous. तो पुराने वाले indexes को ignore कर देगा and new वाले indices number of rows के according दे देगा. Then we can print the new class distribution after balancing by again using value underscore counts function. And if there were no yes, तो वो जाने वाला था else block में. So else block में उसका further perform किया है that we can print no yes records are there. And also if you want demo के लिए तो एक new record add कर सकते हो अगर अपने पास कोई भी new record नहीं है तो I have added this new record in our data frame just to demonstrate this कि ठीक है कैसे होता है and all that. Again, going through the same process of recalculating and resampling. So there are a few points to look for again. Resampling, you have increased the number of yes records to balance the data set. The proportion of yes records is increased to 30% in our example that we had discussed कि हमें 30% तक चाहिए था. Handling imbalance, if there are no yes records in the data set, we simulate adding one yes record to make the resampling work. And usage of pd.concat, it is used instead of df.append to add new records to the data frame, which is the recommended approach in the recent version of pandas. And I'm again telling, please ignore the output. because there might be some anomalies, as in the column I had taken zeros and ones and I am performing by yes, because zero would be a boolean or an int. Here we have made it into CSV, so this might pose a problem. So yes, you can ignore the data set and the output. For this case, you just have to understand कि procedure कैसा गया है. Coming on to decision trees. Decision trees is a huge topic, but very easy if you know what it is. Basically तो tree node बनाना होता है. But how? Let's get into it. So decision tree is a supervised machine learning algorithm used for both classification and regression tasks. It's like a tree model in which internal node represents a decision based on a particular feature of the data. Each branch represents an outcome of decision, and each leaf node represents a final decision for classification or prediction. फाइनल डिसीजन किसमें होता है? क्लासिफिकेशन में, और प्रेडिक्शन होता है रिग्रेशन में. So decision tree is a supervised ML model, ML algorithm for both classification and regression tasks. And इसके की characteristics main 5 होते हैं. Root node क्या होता है? The topmost node जो पूरे data set को represent करता है, which can split into two or more subsets. Internal nodes are those which represent the decisions based on the features of the data. Branches are what represent the outcomes of the decisions at the internal nodes. Leaf nodes क्या होते हैं? They represent the final outcome or the prediction for classification. This is the predicted class, and for regression, it is the predicted value. और path क्या होता है? Path is root node to a leaf node, which represents a decision rule for classifying or predicting a data point. Decision trees work कैसे करते हैं? Training a tree. During training, the algorithm recursively divides the data into subsets by deciding the feature that best separates the data at each step. सारी steps पे हम divide करते रहते हैं branches में, फिर new nodes बनते हैं, फिर उसको branches में divide करते रहते हैं, again we get the new nodes. So this process keeps on going again and again recursively. Then splitting criteria क्या होता है? A decision tree selects the feature that best splits the data based on the criteria like Gini impurity, information gain, or mean squared error, MSE. You can search about all these algorithms and procedures which have mathematical inferences. And उसके basis पे we can manually make a decision tree बिना coding वाला, लेकिन उसमें बहुत time जाएगा तो code ही देख लेंगे. Predicting में क्या होता है? Once a tree is trained, new data points are classified or predicted by following the path from the root node to a leaf node based on their features. इसके advantages and disadvantages of course आते हैं like everything. Advantages would be interpretability, handles both numerical and categorical data. There is no need for feature scaling, and it handles the missing values as well by ignoring the missing values during the decision making process. And इसके disadvantages could be overfitting, instability, and bias towards the feature with more levels. So decision trees tend to prefer the features with more categories or distinct values. Small changes in the data can lead to completely different tree, and trees can easily become too much complex and overfit the training data, meaning that they might not generalize well to the new data. अब टाइप्स ऑफ डिसीजन ट्री मेन तो टू होते हैं. वन इज क्लासिफिकेशन, वन इज रिग्रेशन. क्लासिफिकेशन में मोस्टली हम लीनियर ग्राफ प्लॉट कर सकते हैं. रिग्रेशन का ग्राफ मोस्टली यू नो ऐसा लॉग जैसा होता है. लॉजिस्टिक रिग्रेशन, लीनियर रिग्रेशन. You can study more about it if you are interested from the internet or even ChatGPT. So classification trees, it's used for classification task where the output is mostly categorical like yes or no, and regression tree is used for regression task where the output is a continuous value. For example, predicting prices of stocks. So popular decision tree algorithms mostly do होती है, which we will be discussing in this video. That is CART and C5.0. CART is classification and regression trees. It builds binary trees by splitting the data at each node into two branches using a criteria such as Gini index or MSE. So for classification, we can use Gini index or Gini impurity or MSE, which is the mean squared error for regression. And C5.0 is just a little above the CART. It's an improvement over C4.5, which was the last algorithm before C5.0. And C 5.0 is more focused on classification tasks and is known for its efficiency and accuracy and using techniques like pruning and boosting. So keeping in mind the length of this video, I think I should wrap this up here only and continue the next part, that are building card decision trees, building C 5.0 decision trees, and building random forests using Python in the next video. Hope to see you there, and let's study more in the next video. Thanks again.